Now for the lesson 4.1 quiz solutions. So number 1 is just D. Number 2, we have energy is power times time equals current times voltage times time. And since V equals IR, we have that equals I squared R times time. So if we double the current, then we will have 4 times the energy. So that is B. Now number 3, we have energy is 20 by 10 cubed joules, and that means 20 by 10 cubed watts times seconds. So the power is energy over time, which is 20 by 10 cubed over 25 hours, each 60 minutes, each of those 60 seconds. So we end up with 0.22 watts. Then we have P equals VI, where V is 3 volts. So I is P over V is 0.22 over 3, and that equals 0.074 amps. So then the resistance, voltage over current, is 40.5. So that is closest to 40 ohms, and that was A. Now question 4, writing what we know, we have 16 amps and 240 volts. We have the time is 45 minutes, which is 2,700 seconds. Now, the power in the dryer is 3840 watts. And the power used by the computer is 324 watts. So in fact, the easiest way to approach this problem is to look at it in terms of ratios. So the time for using the computer over the time for using the dryer, since energy is power times time, those time for the computer over the time for the dryer is the power of the dryer over the power of the computer, and that means the time you can run the computer is power of the dryer over power of the computer times the time the dryer runs, and that turns out to be 533 minutes, or that will be 8.8 hours. And number 5, we have power equals VI, which is 120 by 8.5 equals 1020 watts. Energy needed to heat the water. That's given by, that energy is Q, and we have MC delta T. Now delta T is the change from 21 to 100, so that is 79 degrees rise in temperature. So Q is 2.4 kilos times 4186 times 79. Turns out to be a large number of joules. So now we have the time is the energy over the power, since energy equals power times time, and that turns out to be 778 seconds, which is pretty close to 13 minutes. Now for number 7, the first thing we do is find the resistance of the parallel pair. Now the easy way is to notice that they are equal, and so the resistance is half, but the thorough way is to use the equation. So we have 1 over 576 plus 1 over 576, 2 over 576. So that means Rp equals 576 over 2. And however you got it, the resistance turns out to be 288 ohms. So the total resistance is that resistance of the parallel pair plus the one in series. So we have that 288 plus another 576. So we have 864 ohms in total. So the total current, we're just using Ohm's law. We have 120 over 864, and that gives us 0.139 amps. Now that will be the current through resistor 1 because it's got the total current through it. The current through the others, well, we know it has to split equally, so it has to just be the total over 2, and that is 0.069, I think, amps. So then we can work out the power in resistor 1. Since we're just looking at current and resistance, we've got I squared R, and that gives us 0.139 squared times 576, which is 11.1 watts. Power 2 is power 3, is I2 squared R2, which is equal to I3 squared R3, so 0.069 squared times 576, and that gives us 2.78 watts in each of those.